Have you ever had this problem? You create an app and it works perfectly on your machine. You create a repo, push it to GitHub and clone it on another machine in school, work, or university. You try to run it and bam, you get a library not found error, or a DLL error, or maybe your compiler has a different version. It works on your machine, but only on your machine. And here's where Docker comes to play. Docker is used for deploying software applications so that they work everywhere on every machine. The two main concepts in the Docker world are the images and containers. A Docker image is a packaged application that contains all the libraries, dependencies, and other software. It is typically defined by a Dockerfile. In this Dockerfile, we can specify additional commands like copy to copy your source code, workdir to specify the working directory, or run to execute Linux commands. A Docker container is an instance of this application. We can configure a container via command arguments, environment variables, and ports. Okay, so let's see how this works in practice. We are going to run a simple Python backend app in a container. I'm going to create a simple Docker file. Well, first, the Docker file has to start with a from instruction. This instruction copies a different Docker image to our file, basically. I'm going to use the Alpine image because it's quite lightweight. Okay, and that's a completely fine Docker file. So to build an image, you have to do docker build dot, because the Docker file is in our current directory. If we run now docker images, we will see our image. Well, it does not have a tag or a repository, but it works. We can do docker run and then the image ID. We don't need to copy the whole ID. For example, the first few letters are enough. Well, but this didn't do anything. That's because we didn't specify any command. We can do, for example, an ls to list the contents of this image, and then it immediately stops. Or we can do here I check the contents of the var folder, and it still works. To interact with this container, you have to run it in the interactive mode. So we need to specify two flags, I and T. Next, let's use the image ID and then the shell command. Now I'm inside the container. I can interact with it like with a normal Linux system. To exit from the container, just type exit. Let's set the working directory of our application. To do that, we have to use the workdir instruction. We're going to simply call it simple docker/myapp. We can build our image again. But now I would also like to specify a tag. We do that with a T flag. I'm going to call this Python example v1. Now if we list our images, you can see the repository is called Python example and the tag is v1. Okay, so let's run this image also in the interactive mode. And as you can see, now instead of being in the root directory, we are in the simple docker/myapp directory, which is what we wanted. Okay, now let's create a simple backend Flask application in Python. So we need an app.py file and also a requirements.txt file. We'll need Flask. I'm going to use version 3.1.2, and we also need Gunicorn. And we also need Gunicorn for later. Okay, so let's also create a simple virtual environment, activate our virtual environment, and let's do pip install -r requirements.txt. Nice. Okay, so I've created an app.py file. This simple application will be a calculator that will have two endpoints, add and subtract. This is the from Flask import Flask and request. Let's define the app. So the first route will be a test route. So in the decorator, app.route, and this will be called hello just to check if everything works. Turn hello world. Now if dunder name equals the name, let's run the app on port 8000. Now if I do python app.py, this app will run on this port. If we go to that address in our browser, we will see hello world. Okay, let's add two more endpoints. First, I would like an add endpoint that is going to add two numbers, and then also a subtract endpoint. Okay, so let's finish this one first. So I would like to get two URL parameters. I'm going to call them A and B. This is going to be A equals request.args.get A. And B is going to be pretty much the same. We also have to convert them to integers, because they are strings by default. And let's return an answer. A plus B. Here let's do just pass for now. Now we have to rerun the application. Go to /add. For example, let's try to add 1 and 4. I'm going to get 5. Oh, okay, so this works. But if I try to get A here, I'm going to get an internal server error. So we need to handle an exception. Let's do a try except. And here, if this does not work, I'm just going to now return a message something went wrong, right? An error. Okay, we can pretty much copy this. Just change this to a minus. Let's see again. Okay, error invalid literal for int. Okay, let's try subtract, and it works. Nice. Okay, so now let's run this application in the Docker. Well, first we must have Python installed. Fortunately, we don't need to run any apt-get commands or some other weird stuff. We can just change the base image. So instead of this base Alpine image, I'm going to use a Python image with the new 3.14 version. It's like this. You can find those images on the Docker hub. Now we need to copy the app.py file to our working directory. Okay, so let's try to build our container again. So let's do docker build dot, and let's add a tag Python example v2. And as we can see, our image has been created. Let's run this image in the interactive mode. And as you can see, if I type ls, I get my app.py and my requirements.txt. And the contents of those files are the same. Oops, I meant this. Okay. Let's see if Python works. Here, if I type Python, nice. We get our interpreter. And let's check if pip install also works. And as you can see, all of our dependencies have been installed. But we don't want to do that manually. We can just do that here in a very simple way. We just do run pip install -r requirements.txt. Well, and as the name suggests, this instruction simply runs this. Okay, let's check that. If I run this image again, those dependencies should be installed. And as we can see, there we go. Nice. If I run the Python example image again, this still stops immediately. And we don't want that. We need an entry point and a command to finish our image. So an entry point only starts when we run the image. For example, let's do ls before we go further. So docker build .python example v3. Oops, and the tag flag here. Now if I run this, we automatically get the contents of the working directory. And the arguments after this will get passed to our entry point. So if I want to ls the previous directory, I can do double dots. And maybe let's do it again. Now I get the root directory. So as you can see, this gets passed to the entry point. Okay, but to run our Python app, I'm going to use Unicorn, which stands for green unicorn, by the way. And then we can specify those commands here. So for example, let's try maybe 2 workers. We need to bind our application to 0.0.0.0:8000 so that it is visible on the host machine. Now let's do app:app, which is the name of our file. Now, finally, if I do docker.build again, then I have to use docker run, but I also have to use the -p argument and set it to 8000 :8000. So this binds the port on my machine, on my computer, to the port on this Docker container. So Python example version 4. As you can see, the unicorn has started. Let's see if this still works. Okay, hello world, nice. Let's try to add 10 and 15. We get 25. We get -5. Nice. Well, I can change the port that will be visible on my host machine here. For example, let's do 1, 2, 3, 4. So in the container, this still runs on port 8000, but well, it no longer works here. We need to change this to 1, 2, 3, 4. And now we get the answer -5. Nice. And add it's 25. To run our container in the background, we can just add a -d flag at the beginning here. Now if we do docker container list, you can see that our container is running. It is based on image Python example version 4, and it was executed with this command. Well, but we created quite a lot of containers in this episode. If we do docker ps, which is basically a shorter version of this, -a, you can see all of the containers that we created. So basically we create a container with every docker run command. Well, we can stop this container. Oops, I meant, sorry, I have to use the container ID. So 21b. We don't need to copy everything here. Docker figures out automatically that we meant this container. If there are any conflicts, where it will tell us that. Okay, so currently there are no containers running, but there are quite a lot of stopped containers. Well, we can delete them one by one using docker container remove, then the container IP. As you can see, oops, this container is no longer visible, or we can just do docker container prune to remove everything. Now there are no containers anymore. Well, here we also have our images. And you can also just do docker image remove and then the image ID or the repository and the tag. But to delete all, we can just do docker image prune. Warning, this will remove all dangling images. Yeah, I want that. Okay, well, for some reason those images don't want to get removed. But there are no containers of them. Okay, so we can just do docker image remove and remove them one by one. And as you can see, we have no images left. Okay, so thank you for watching this episode. In the following episodes, we will take a look at the Docker ignore file, Docker networking, volumes, and other interesting stuff. So stay tuned and see you later. Goodbye.